All right, we'll take a look at problem 10 and 12 real quick. See how this plays out. Hopefully, I could do this quickly, but not too fast. Okay, so we always know that we start every proof with our given information, and that's that PS and QT bisect each other, right? So that is kind of an interesting given piece of data because I don't know that we've ever done the each other part. So it's like a duel and they cut each other perfectly in half. So that would mean that QR and RT are congruent, but it would simultaneously also mean that PR and SR are congruent because it said they bisect each other. Now, sometimes we like to use some colors, and so that's okay. I'll go ahead and do that. And so if the colors help you, that's great. If they don't help you, it doesn't really hurt to put a little bit on there just to make sure that it's clear what we're talking about. But then my personal take, what I prefer to do rather than using the letters is I like to call them one and two because I know that anytime you see that little crisscross going on, that those central angles in that thing are going to be congruent. So angle one and two are congruent. And so what I can see right away is that I do have a side angle side story. See, green, orange, purple, green, orange, purple. And so it doesn't really exactly tell me what order of letters to use, but I think I'm going to go ahead and use QRP. So if I slid across green and then across purple, if I did that, that would be TRS. And that was true by SAS congruence. Cool. So that's pretty good. But then remember, we have this little thing that says CPCFC that if the figures are congruent, then the pieces are congruent. And the specific pieces that I wanted is PQR. Notice PQR is the same as STR. That's exactly right. That's in the right order, CPCFC. And so, yeah, I guess we got it. All right, now moving to problem 11. We're asking about really the corresponding parts. So this is really a repeat question of the one above. This is an SAS set of triangles, side, angle, side. So that is definitely true. I'm going to write SAS here because I know that that is true. But remember, when we look at figures, we want to make sure that our order is right. So ABC is 2, 1, 3, should be 2, 1, 3, DEC. And that was actually done right. That's CPCFC. Now, how about BCA? BCA should be ECD. And that is also, it looks like, true. It looks like we actually did a pretty nice job lining those particular pieces up. So we're doing pretty good so far. Then we have AB matching CD. Is AB matching? AB is supposed to match DE. So we screwed that one up. That's not true. Unless that BE, let's see, BE, wait a minute, BE is not even part of the triangles. So B to E is the same as D to A. No, both of these together could be very different than those two together. So that's silly. So we've got 3 trues and 2 falses. Okay, cool. And so now here we go with our next little piece. Now, the directions here we do need to fix for the future. We really have only dealt with 2 shortcuts, which are ASA and SAS. So those are the only ones that we would have to choose from in this particular situation. So one thing you want to remember is that if you ever have information about parallel lines, now keep in mind, I'm saying those lines are parallel. I did not say they are congruent. I just said they're going the same direction. But parallel lines always give us information about angles. So remember, I'm going to grab something about an angle. I'm going to use alternate interiors in here somewhere. But I also know that BC bisected AD. So BC is the knife that cut AD into 2 equal pieces. Now, this is not a proof, so I can just write some information down that I know very quickly. I also know, like the previous questions, that vertical angles are going to be easy. So what I have right now, if I've got a side, I've got an angle, and I've got parallel lines. So if I could just use these two angles right here by alternate interior angles. Now I could have done the top one, but I'm really only looking for ASA. So the side has to be in the middle of those two angles. And that is absolutely congruent. And that was the ASA theorem or postulate. We actually have talked a little bit about the fact that some people call it a postulate and some call it a theorem. Um, Letter B. This is a little bit of a trick question, if you will, because I do see the ASA here, but I don't see ASA here. But the third angle theorem, see, if that's a 70 and a 60, those add up to 130, which makes this one 50. That's the leftover. And in fact, yes, I did get ASA again as well. Again, theorem or postulate, depending on it. Okay, this is really actually very, very funny because it's sitting side by side. These other two were exactly the same problem as the one that's listed out here. That is a yes by SAS. Same exact problem that we had before. And our last one, letter D, because of the reflexive property, GI is the same as itself. And so that is definitely true by SAS. So that ends that particular page. Hopefully that was helpful, and I will see you guys back in class. All right, bye now.